Everyone, good morning from Bangkok, and for those in the Mekong region, and good evening for those in the United States. My name is Ekapon Siri Chavanishakar, and I'm the MC for the event. Welcome to SERVIR-Mekong Symposium, leveraging geospatial technologies for solving the climate crisis. Today is the first day of the 5-day webinar series to understand the application of geospatial technologies in addressing climate change. As the usual rules apply, please keep your computer microphone muted and camera off during the session unless directed otherwise. For the audience, if you have any questions or comments, please do not type them in the chat box, but please type them in the Q&A box instead, since we reserve the chat box for the panelists and the moderators. So let's begin the proceeding today. First, let me start with introducing Mr. Hans Gutmann, the Executive Director of ADPC, for the welcome remarks. Mr. Hans Gutmann joined ADPC in 2017 with over 25 years of policy and development experience, specifically in the fields of rural development, water resources management, environmental management, water diplomacy, and international cooperation. He has over a decade of practical experience in implementing on-the-ground sustainable rural development initiatives at the local, national, and regional levels in the Southeast Asia. Prior to joining ADPC, he was the CEO of the Mekong River Commission Secretariat, supervising the implementation of the 1995 Mekong Agreement as coordinator for the Wetlands Alliance Program. He managed 50 agencies in 5 countries to cooperate in aquatic resources management for poverty reduction in the Mekong region. Mr. Gutmann, please.
Thank you. Good morning and good evening to all of you joining us from across the world. Stephen Olive, the Mission Director for USAID in Asia, Mission Director for Asia, I meant. Barbara Ryan, Executive Director on World Geospatial Industry Council, Professor Benjamin Horton, Director of Earth Observatory in Singapore, other very distinguished participants, ladies and gentlemen. It is my pleasure to welcome you here to the opening plenary of the SERVIR-Mekong Symposium. Today we'll begin a series of 5 webinars under the theme Leveraging Geospatial Technologies for Solving the Climate Crisis. Across the 5 days, we will hear from experts who have an opportunity to share your views and various aspects, starting from having an understanding of climate change and its consequences broadly, to diving deeper into how climate change would impact floods and water resources, drought, food security, forests, as well as air quality. But the most important aspect of the symposium is for us to understand together how geospatial technologies such as satellite-based observation can help us address these issues. And the ultimate goals of this symposium are to strengthening the application of geospatial technologies in addressing climate change and increasing the number of stakeholders using geospatial technologies for climate change-related decision-making. Climate change is real and will affect everyone. And the 6th assessment report from the IPCC, the physical science basis, released back in August, reiterated that human influence is unequivocally responsible for climate change. And the COP26 climate change conference in Glasgow, Scotland in upcoming November, is expected to take unprecedented commitments and multilateral response to adapting to and mitigating climate change, though, as usual, a lot of questions will probably remain. Countries in Southeast Asia stand to lose a lot to climate change, as their vulnerability to climate changes is very high. Cities such as Jakarta, Bangkok, Manila, Surabaya, and many others are seriously threatened by the increasing floods, rising sea levels, and subsidence together. You may have followed the news in the recent times here in Thailand, or so you know what I'm talking about there. Floods in Vietnam in June, and across the world in China and Europe as well, and a summer of disasters affecting many areas around the globe. SERVIR-Mekong is a joint development initiative of the United States Agency for International Development, USAID, and National Aeronautics and Space Administration, NASA. And the SERVIR-Mekong is implemented by Asian Disaster Preparedness Center, ADPC, in partnership with Deltares and the Spatial Informatics Group and the Stockholm Environment Institute. ADPC is an autonomous international organization that works to build the resilience of people and institutions to disasters and climate change impacts in Asia and the Pacific. And our activities contribute to achieving the overarching objectives of the Global Development Framework, such as the Sendai Framework for Disaster Risk Reduction, the 2030 Agenda for Sustainable Development, and the Paris Agreement on Climate Change. ADPC began the journey with USAID and NASA to start the SERVIR Hub in the Lower Mekong back in 2014. And since then, with the geospatial capacity enhanced by the SERVIR-Mekong and embedded in our Geospatial Information Department, we have been able to deliver important outcomes, such as helping the Mekong River Commission, or MRC, to increase the accuracy with 25 to 50% in some area of its flood forecasting and warning, and the lead time from 6 days to 15 days. And with the development and provision of drought indices for the MRC regional drought monitoring program, we have helped support improvement in that area. We work on delivering and integrating drought information into Vietnam's monthly drought bulletins, particularly in Ninh Thuan province, and supported flood relief recently in Cambodia in collaboration with the government of Cambodia and the World Food Programme by providing improved imagery of the flooded areas. And finally, an example is working on to improve Thailand's air quality monitoring and forecasting in collaboration with Thailand's Pollution Control Department and Geoinformatics and Space Technology Development Agency. These examples shows that collaboration and partnership is a key important for the successes. ADPC values partnerships with regional organizations that helps provide a platform for cross-boundary learning and scaling. We also value the partnership with national and subnational stakeholders, including governments, NGOs, academia, to help us bring our interventions to create sustainable change on the ground. Combining enhanced geospatial capacity with ADPC's existing knowledge on climate resilience and the connections with mandated climate change and National Disaster Management Agency, ADPC is in a very good position to work with USAID and NASA to continue to support regional and national climate change adaptation and mitigation efforts. So going forward, we look forward to work closely with USAID and NASA and other partners to co-create the next phase for the SERVIR-Mekong. In conclusion, I would like to thank you for joining this very important event from all across the world. And we have a great lineup of speakers for different sectors and geographies with varied expertise and perspectives. And I encourage you to use this opportunity not only to gain new insight and build new partnerships, but also ask questions which will enrich these discussions. I would also like to thank our SERVIR-Mekong collaborators, the SEI Stockholm Environment Institute, SIG, Spatial Informatics Group, and Deltares. And a special thanks to Dan Irwin, the Global Program Manager for SERVIR NASA, for all of your support and engagement, which has helped making SERVIR-Mekong a success. Thank you once again, and I look forward to the discussions today and in the days ahead. Thank you very much.
Thank you very much, Mr. Gutman, for the welcome remarks. Next, let me introduce Dr. Steve Olive for the opening address from USAID. Dr. Olive is the Senior Foreign Service Officer and the Mission Director for the Regional Development Mission for Asia at USAID. From 2018 to 2020, he served as the Senior Deputy Assistant Administrator for USAID's Latin America and Caribbean Bureau. In 2017 to 2018, he was the Acting Director of the Foreign Service Center in the Office of Human Capital and Talent Management at USAID Kenya and East Africa, based in Nairobi. He served as the Deputy Mission Director for Somalia from 2014 to 2017, and concurrently served as the Acting Deputy Chief of Mission for the U.S. Mission to Somalia from 2016 to 2017. Prior to joining USAID Kenya and East Africa, Dr. Olive served as a Deputy Mission Director for USAID Haiti from 2011 to 2014, leading post-earthquake reconstruction and development efforts. He was also posted in Peru and Nicaragua from 2002 to 2011, managing environment, trade, agriculture, food security, and emergency response programs. Dr. Olive, please.
Thank you very much, Kun Ekapon, for your kind introduction. This is really a day I've been looking forward to. I think the series of webinars that all of you are about to receive, you're going to be very excited about. It's a great honor for me to share this opening session with Hans Gutmann, the Executive Director of the Asian Disaster Preparedness Center, who we just heard from. And then you're really going to look forward, you're really going to enjoy interacting with Dan Irvin of NASA's Global Program Manager for SERVIR. We have a great lineup for you all in these webinars. It's certainly a very timely topic, as Hans outlined very clearly in his remarks. And so again, it's an honor to be with all of our guests and viewers from around the world as we kick off this first of the 5 webinars on the role of geospatial technologies in solving the climate crisis. Thank you to SERVIR-Mekong Project for organizing this symposium. SERVIR-Mekong is a long-standing and successful partnership between USAID and NASA. The project harnesses NASA's publicly available geospatial technologies to help governments and citizens respond to climate-related challenges. And I've been here in Bangkok, Thailand for a little over a year, and I'm always impressed and amazed and thankful for how often people come up to me and thank us for the SERVIR-Mekong project and all the advances, especially the technology advances that the program has been doing in this area. And that's why the timing of this symposium is critical. In less than 1 month from now, leaders from around the world will gather in Glasgow for COP26 of the United Nations Climate Change Conference to discuss how we will approach the climate change crisis together. The impacts of climate change, one of President Biden's highest administration priorities, transcends boundaries. As temperatures rise, precipitation intensifies, forest fires become more frequent, and droughts are prolonged, vulnerable communities are often the most affected. Climate-induced disasters, including flooding caused by unpredictable and excess rainfall, can further marginalize populations and potentially undo decades of development progress. At the United Nations General Assembly, President Biden announced that the United States will double its climate investment by 2024 to $11.4 billion per year to help developing nations reduce carbon emissions and adapt to the impacts of climate change. While funding is subject to congressional approval, the announcement is a clear indication that bold and determined steps are essential to confronting the challenges brought about by climate change. I'm also very pleased to announce USAID has appointed Jillian Caldwell as our new agency climate change coordinator. She will also serve as the Deputy Assistant Administrator for our Bureau for Development, Democracy, and Innovation. Jillian will be responsible for directing and overseeing the agency's climate work, including finalizing the new USAID climate strategy that reflects the ambition, prioritization, and urgency needed to address the global climate crisis. The strategy will connect to USAID's entire portfolio, from food security to global health and gender equity. The strategy will support action-oriented roundtables, such as today's webinar, that build support for policy and regulatory changes that prioritize climate change in all sectors and enhance the adaptive capacity of countries across the Indo-Pacific. And when the strategy is ready, I'd be very pleased to share it with all of you and hope that you all will take a look at it, please. A central tenet of our climate change work is the vision for a free and open Indo-Pacific. We support regional partnerships that strengthen sustainable management of shared natural resources and build transparency in natural resource management decisions. USAID supports governments and regional organizations to implement ambitious emissions reduction measures. We work to build regional energy security and ensure the supply chains are better prepared to respond to weather-related shocks and stressors. In doing so, we increase the resilience of communities and businesses to climate change. Through the SERVIR-Mekong project, USAID has partnered with United States scientists from more than 20 US universities and research centers and various United Nations agencies to promote this work. We have worked closely with the Royal Thai government's Pollution Control Department and the United Nations Economic and Social Commission for Asia and the Pacific, or UNESCAP, to improve air quality in compliance with the ASEAN Cooperation on Transboundary Haze Pollution. We are grateful for our regional partnership with the Mekong River Commission to be able to provide satellite imagery, data, and decision support tools to assist in disaster reduction measures across the region, including in implementing the MRC's drought management strategy for 2025. As a result, farmers have advanced information to mitigate the impacts of drought on their crops, and policymakers have better data and tools to develop and implement drought prevention mitigation strategies. As part of its broader effort on climate change, in June of this year, USAID expanded its participation in 3 multilateral partnerships to help countries that are vulnerable to climate change: the INSU Resilience Global Partnership, the Risk-Informed Early Action Partnership, and the Global Facility for Disaster Reduction and Recovery. All 3 of these partnerships provide countries timely and reliable disaster response through early warning systems. They provide solutions to strengthen resilience for the communities hardest hit by climate change and help countries better understand and reduce their vulnerability to natural hazards. Central to these partnerships is the importance of early warning to increase the resilience of communities and businesses to weather-related shocks. This region is disproportionately affected by climate change because of the high concentration of vulnerable populations living along the coastal areas and river basins, as Hans also mentioned in his remarks. SERVIR-Mekong is uniquely placed to support countries to advance these early warning systems to protect lives and livelihoods through state-of-the-art geospatial technologies. Recognizing the critical role that Southeast Asia has for the rest of the world in both reducing emissions and adapting to the impacts we are already seeing, we are hopeful that partnerships such as SERVIR-Mekong continue to exemplify what we can accomplish together. The impacts of climate change will transcend generations and transform everyday life as we know it. We must take bold and urgent actions to protect the natural environment. Future generations are counting on all of us. Thank you for taking the time to be here today and for spreading the word about the Symposium series with others. I encourage you to build on these partnerships to leverage and leverage other partnerships as we all jointly address the challenges that lie ahead. Kapku Mak Nakrab, thank you. And now let me pass the floor back to Kun Ekapon. Thank you.
Thank you so much, Dr. Olive. Next, let me introduce Mr. Dan Irwin for the opening address from NASA. Mr. Irwin is a research scientist at NASA Marshall Space Flight Center and the Global Program Manager for Serbia. He has over 25 years of experience in satellite remote sensing applications and GIS in the developing world. He also served as a lead remote sensing specialist in support of NASA's Space Archaeology program with a focus on detecting structures of the ancient Maya. Prior to joining NASA, he lived and worked in Guatemala, developing leading GIS laboratories for conservation organizations and the Guatemalan government. Mr. Irwin, please.
Yep, thank you so much. And thanks to Hans and Steve for your meaningful and relevant remarks. I'm so honored to be here at the SERVIR-Mekong Symposium and want to thank everybody for joining. Also a special shout out and thanks to Napak at USAID and Puranin at ADPC and the whole SERVIR-Mekong team for putting on this awesome event. I am so fortunate to be able to work with such an amazing group of people. And this is such an important time to be having conversations on climate change. Back on May 3rd, on the very same day, both NASA and USAID welcomed new administrators who have both pledged that the missions of our agencies would take on a greater role in combating the effects of climate change. And moreover, as Steve mentioned, both of our agencies have recently appointed climate change advisors, and we're so pleased that USAID has their new advisor, Jillian. And as our NASA and USAID collaboration has strengthened over the years, so too has our commitment to fostering climate resilience around the world. And just last week, just a few days ago, NASA launched Landsat 9, the latest addition to our growing fleet of powerful Earth observing satellites. And I'm not sure if you saw the launch, but it was so incredibly moving because for nearly 50 years, the Landsat program has been building the world's most complete library of Earth data. And with Landsat 9, our journey continues. And it's amazing to have Barb Ryan in the next panel coming up because when she was with USGS, she was instrumental in making the Landsat archive free and open. And on top of that, NASA has an upcoming Earth System Observatory where 5 new satellites are going to provide new observations, collecting new information from the Earth's surface up to the atmosphere. And this is sure to open up exciting new possibilities for exploring, for understanding, and protecting the beautiful complexities of our home planet. And since NASA and USAID came together to form SERVIR, our mission has been to work with organizations and communities on the front lines of our greatest environmental challenges to better use that data. And this symposium is such an exciting opportunity to explore what's been achieved and what's possible when we share the power of Earth science with the best and brightest to address climate change and other related threats facing our planet. And the Mekong region, as was mentioned in the previous talks, is incredibly important to the future of our home planet, its biodiversity, its importance to global agriculture, and of course, its exposure to natural hazards and such as cyclones and others. The Mekong is so critical to implement applied Earth science. And led by the Asian Disaster Preparedness Center, SIG, Deltares, and the Stockholm Environment Institute, SERVIR-Mekong has become part of an incredibly powerful network of actors in the region. And this network is strengthened by essential national government partners and regional organizations like the MRC, who are all helping to turn satellite data into climate action. And key technology partners, intergovernmental and private sector partners like Google and FAO and the World Food Program are making this network more powerful than ever. And for example, SERVIR-Mekong's Air Quality Explorer tool is helping Thailand breathe easier. Its hydrofloods, near real-time flood mapping and monitoring tool has not only been useful in the Mekong region, but it's actually gone on to support disaster response in other places around the world, especially following hurricanes in Central America. And the regional land cover monitoring system, first launched by SERVIR-Mekong, it was so successful that just last week it was launched, and there's been a replication process by SERVIR Hindu Kush Himalaya. So it's really amazing to see this transfer of capabilities from SERVIR-Mekong around the entire planet. And SERVIR-Mekong is also pioneering sustainable climate resilient practices for agricultural supply chains using space technology to help keep food on the table. So next month, the world's climate leaders will convene for COP26 to plan the future of climate action. And as we exchange ideas and we exchange inspiration in this symposium, remember that what we learn here is not just important for the Mekong region itself, but also setting an example for the rest of the world. I look forward to seeing the big ideas that arise from this symposium and want to thank you for helping us build a climate resilient future. Thanks again and wishing you all a very successful symposium.
Thank you very much, Mr. Irwin. Next, we have a short video clip from USAID in support of the Biden administration's agenda to tackle the climate crisis. USAID plays a key role implementing climate solutions in more than 45 countries around the world. So here's the video.
On day one, I signed the paperwork to rejoin the Paris Climate Agreement. We can no longer do the bare minimum to address climate change, and we'll all suffer consequences if we fail. We desperately need a unified response to the climate crisis. When we strengthen our alliances, we amplify our power in order to live in peace, security, and prosperity. And I want you to know the United States will do our part. We'll stand with you. We'll fight for our shared values. We'll meet the challenges of this new moment in history.
All right, thank you. So next, let's move on to the panel discussion for today. The moderators for the panel discussions for today are Dr. Pirnan Towashirapon, the Chief of Party for SERVIR-Mekong, and Mr. Ankit Joshi, the Communications Lead of SERVIR-Mekong. Dr. Pirnan and Ankit, the floor is yours.
Thank you so much, Khun Ekapon, and good morning to all of you in Asia, and very good evening to you from the other side of the world. Now it's a good time for us to lose our tie a little bit and transition from the opening session of this SERVIR-Mekong Symposium Session 1 to a more conversational mode. You'll hear today from a number of experts and leaders in the field of climate change and geospatial applications on how they have done their work to address climate change issues. So before I begin, can I invite all the panelists to turn on the camera, please? Today's sessions serve as a foundation for the rest of the symposium. This particular session will give you an opportunity to understand a bit more about climate change and moreover on the impact that you and every one of us may feel in the near future, while at the same time learning on how we can use technologies, particularly geospatial technology, to help and guide us on how we can adapt to and mitigate climate change. Today, we have a group of esteemed experts and diverse group of experts too, and diverse in terms of locations and in terms of sectors. They're joining us at the panel discussion. They will share their aspects of experience on climate change. But we would love to hear from you as well. I ask that you put your comments and questions on the Q&A box at the bottom of the screen. You can see that option right on the bottom of your screen there. Please also, if possible, indicate which panelist you want to your question to be directed to. So let us begin. We will start with, I will ask the panelists to give a short 10-minute intervention on their work. After that, we'll open the floor to take questions. First, starting with a moderated discussion by me, and then we'll select key questions from the audience to ask to the panelists. Our first panelist is Ms. Barbara Ryan. Barbara currently is the Executive Director of the World Geospatial Industry Council. She brings with her immense leadership experience in managing and advocating for greater collaboration among national and international organizations, such as the US Geological Survey, the World Meteorological Organization, the Group on Earth Observation, or GEO. Today, Barbara will tell us a bit about her experience under the topic of Observations from Space, Advancing Climate Action. Barbara, the floor is yours.
Well, thank you very much, Piernan. It's really indeed an honor to be here. And as you said, actually already in the comments, the introductory comments that have been made, I think you're going to see some themes that emerge. So I would like to talk about observations from space and advancing climate action. Next slide, please. You know, for this entire area, I think there are some enabling conditions that we need to talk about. Important is open data. I think Dan may have referenced that in his opening remarks. Leveraging the past, better integration and coordination, and hyper partnering. And actually, if you listen to very carefully, the linkages to the policy mandates, whether it was the Paris agreements or the Sendai agreement or the SDGs, I think it was Hans that mentioned each one of these in his remarks. And then also, if we just go back a little bit to that hyper partnering, that's terminology that we've been using, but the importance of just partnering with organizations. Really, it was Steve that mentioned that. So already in those introductory comments, we've heard some enabling conditions. Let's go to the next slide because I'd like to touch on each one of these enabling conditions. You know, our success or experience in the Landsat program really dated back actually several decades. As Dan mentioned, the Landsat 9 satellite was launched a week ago, but the first Landsat satellite was actually launched in 1972, and the United States sold data from that satellite. And I have to, and largely it was my organization, the U.S. Geological Survey, that U.S. Geological Survey, that was responsible for the data sales aspect. NASA, and I'll give Dan a lot of credit, NASA had been advocating for a long time that that data should be broadly and openly available. So if you were to look at this particular graph, this graph starts out at 2008 when the policy change occurred, but from 1972, from the launch of Landsat 1 all the way up to 2008, the data was sold at $400 or $500 a scene. Now, we were successful in 2007 and 2008 to get that policy change in place. And that one data policy change alone involved going from 53 scenes a day to 2 orders of magnitude, 5,700 scenes a day. Now, I think the important thing from an open data perspective globally is, of course, it's good to get more data out there, but I don't think any of us actually expected the economic benefit to come out as or as robust as it's shown in this graph. Now, I retired from the Geological Survey in 2008, shortly after the policy was changed. This economic analysis was done in 2011, and it showed that there was more than $1.7 billion of economic benefits that was accrued to the United States, $400 million outside the United States, for a global total of $2.1 billion. That's an annual economic benefit of $2.1 billion. That far exceeds the $5+ million that we were collecting from selling those 53 scenes a day. So I think what, and we, of course, we're happy to see that Europe followed in the United States footsteps for the entire Sentinel series and the Copernicus program with a broad open data policy. So the number one message today is that any government that is in fact using taxpayers' money to build and launch satellites, although I would argue to build and launch any observation schemes for whether it's atmospheric, oceanic, or terrestrial observations, if taxpayer money is being used to collect that data, it should be broadly and openly available. Not only will it spur on economic involvement, economic benefit, as you can see from this experience in the United States, but it will in fact enhance the academic research that is done from your research institutes, not only on the government side, but on the private side around the world. So the importance of open data is just so critical. If we go to the next slide, what you will see is that it's really important that we build on what's being done. This is an example from an area not too far from where you are, the continent of Australia, that ingested the entire Landsat archive into a national computer center. Now, honestly, whether it's in the cloud or whether it's in a national computer center, it doesn't matter. But the point is Australia took 27 years of Landsat data, 25-meter pixel resolution, 300,000 scenes, and they were able to superimpose a water algorithm over this and get every single pixel, 25 meters by 25 meters of all the data, all the land mass that had always been dry, always been wet, or sometimes dry and sometimes wet, down to 3 hours of compute time. So the importance, they happen to call it a data cube, but the importance of ingesting this, whether it's Landsat data, Sentinel data, or any data that's broadly and openly available into continental scale analyses, is just so important. We must build on what's been done rather than reinventing the wheel. Next slide. Better integration and coordination, whether it's internally within our respective organizations, whether it's nationally among our respective national entities, regionally on continent-wide efforts like what you folks are doing with SERVIR and in the Mekong River Basin, or whether it's globally, an organization that I used to work for, GEO, or any other organization that is in fact delivering those policy linkages that we referenced earlier, are just so important. We've got to do a better job of integrating and coordinating among and between ourselves. The next slide shows that I think it was actually the investigative journalists that coined this word hyper-partnering, but whether it's public, academia, not-for-profits, or private sector, we've just got to do a better job of building bridges among each of these respective organizations. And the next couple slides are going to show an example of that. So let's transition to the next slide. This is some work that GEO, the organization that I was formerly associated with, on behalf of the public sector, and the organization that I'm associated with now, the World Geospatial Industry Council, on behalf of the private sector, undertook in January of this year the first systematic assessment of greenhouse gas emissions from space. And this graph shows that. You'll see in blue public sector emissions, in red private sector emissions, and in yellow hybrid emissions, which are both public sector and private sector emissions. So what you will see for the 4 greenhouse gases that are actually acknowledged by the Conference of the Parties, the United Nations Framework Convention on Climate Change. So whether it's carbon dioxide, methane, nitrous oxide, or ozone, these are the emissions that are in orbit and or plan to be in orbit to monitor these gases. So I think what's so important is that we leverage the past and expand on partnerships along with that hyper partnering slide that I had before. What you will see in the 1990s and in the 2000s and really even into the 2011s, it was largely private sector missions. So organizations like DAN's, whether it was NASA or ESA, that the real workhorses of Earth observations are shown here. If we go to the next slide, which takes this same data but portrays it on a percentile, you will see in that first decade from 1991 to 2000, it was 100% public sector missions. The same for the next decade. It only was in 2011 to 2020 that you started to see the private sector come into the picture with greenhouse gas emissions from space. And as we look to the present until the future, you will start to see hybrid missions. That is, partnerships between the public sector and the private sector that will start monitoring these gases from space. The next couple slides, just real quickly, will show you what countries are flying those missions. You'll see those countries along the bottom of this graph. Green is shown in orbit. Many more countries are shown in yellow, which will be those countries that are have missions that are in development. And the next slide, I think, will show you the status of whether they are public sector, private sector, or hybrid missions. So again, you will see those countries that are making tremendous contributions from a public sector perspective. You will see those countries that are starting to come to the table with either private sector missions, which are either higher spatial, spectral, or temporal resolution, and or hybrid missions where both the private sector and the public sector are coming together. I think the important part for me about this graph is that we have a tremendous history of public sector missions out there. We are now starting to see the private sector come to the table with additional missions, or even as we look into our next decade, we're seeing an expanded partnership with the public sector and the private sector coming together on missions. And again, this is just missions for the collection of greenhouse gases. We could pick almost any additional Earth observation mission, and I think you would see similar stories. So with the next slide, I just want to really end with some work that was said by the Committee on Earth Observation Satellites and their chair back actually almost 20 years ago now, Paul Mason. While in situ measurements will remain essential, and they will continue to measure what cannot be measured from satellites, Earth observation satellites are going to be the only realistic means to obtain the necessary global coverage, and with well-calibrated measurements will become the single most important contribution to global observations for climate. This is a report that CIAS delivered to the Conference of the Parties back in 2006. Now here we are 15 years later, and we, GEO, the Group on Earth Observations, WGIC, are about to deliver the first systematic observations of greenhouse gases from space. I hope it continues as we go into the next 15 years. So in closing, the last slide is just the World Geospatial Industry Council, of which I am the executive director, is a not-for-profit trade association of private sector companies. So if you are in the audience and you are a private sector entity that is working in the geospatial ecosystem, I would love to talk to you about joining WGIC. The last slide just shows our current membership, and our membership categories, which are patron members, corporate members, and associate members. We have a fair number of just small and medium-sized enterprises that come in as associate members. Of course, if you look at our patron members and corporate members, you'll see many well-known companies around the world. And I think that's my last slide, and I'll turn it back to you guys. I'll look forward to the panel discussion in a few minutes. Thank you very much, everyone.
Thank you so much, Barbara. Such an insightful presentation. I think this is a great way to start our conversation, bringing this partnership in the geospatial ecosystem to the front. I just want to remind the audience again, now we start to see some questions in the Q&A box, but please direct your questions to the Q&A box. You can find the box at the bottom of the screen, and we'll pick up the questions for the panelists toward the end of this panel discussion. So the next speaker that we have with us here today is Professor Benjamin Horton. Professor Horton currently is the director of the Earth Observatory of Singapore, and at the same time, he's a professor at the Asian School of the Environment at Nanyang Technological University in Singapore. He has won a number of awards in his career, including being elected fellows of the Geological Society of America and the American Geophysical Union, or AGU. He is, very importantly, he's a review editor of the new sixth assessment report of the IPCC. Professor Horton's research was cited by President Obama in his 2015 State of the Union address as well. So today we'll dive a little bit deeper into his research of interest. We'll learn about his recent finding from the IPCC sixth assessment report on sea level rise. So let us hear from Professor Horton. The floor is yours, Professor.
Thank you for the kind introduction. I'm just going to share my slides. So I hope you can all see my slides now. As was introduced, I'm the director of the Earth Observatory of Singapore. For those who do not know this, it is a research centre of excellence here in Singapore. We have a workforce of approximately 170 people made out of professors, postdocs, graduate students, and associated support staff. Our mission is to conduct fundamental research on earthquakes, volcanic eruptions, tsunamis, and climate change, specialising in sea level rise. And we use this data to try and create safer and more sustainable societies in Southeast Asia. As was introduced, I have quite a long history with the IPCC. In the fifth assessment report, I was one of the chapter authors, and in the sixth assessment report, I became a review editor. Now, I'm sure you've seen a lot of the press regarding the IPCC. It was a mammoth exercise. The IPCC convenes every 6 to 7 years to produce a report. The author team, composed of around 230 authors spread throughout the globe, 65 or so countries. Importantly, for the sixth assessment report, there was significant turnover from the scientists that were involved in the fifth assessment report. So we had around 30% of new authors, which obviously brought a great deal of new science to this review process. The review process is quite simply staggering. When you look at the numbers, we reviewed over 14,000 peer-reviewed articles. As a review editor, we had to respond to every one of the review comments. And I was involved in chapter 9, sea level, which had the highest number. So as a review editor, I had to make sure that our team responded to approximately 15,000 review comments, be those from scientists, governmental agencies, and the general public. Prior to the pandemic, we would convene every year for annual meetings. We show a photo of the scientists that were there for the first meeting. I think I'm over here. And then in the third meeting in France, I'm somewhere in the crowd there. Now, we like to say that there's a huge number of people involved in the IPCC, but when it comes down to the nuts and bolts, when it comes down to projections of sea level, which have so many implications for populations, static infrastructure, ecosystems. It really comes down to a relatively small team of scientists. So approximately 20 of us worked on the chapter 9 to do with sea level rise. What I'm going to present to you today is some of the general findings, some of the take-home messages, some of the methodology behind it, why sea level is quite a complex science to understand, and then we'll just look at some projections before we finish. So the IPCC has a variety of take-home messages, and what was quite pleasing is that the literature for which some of these take-home messages were based around came from the Earth Observatory of Singapore, sort of indicating what an important institute we have here in Singapore. So one of the statements, take-home statements, is that global mean sea level has been faster in the 20th century than at any time in the preceding 3,000 years. A very important statement. This actually relates to something that President Obama mentioned in his 2015 State of the Union. It indicates that we're living in a very unusual time. And we've done a lot of work at the Earth Observatory of Singapore on looking at the past and the present as a context to the future. This particular image is taken from one of the graduate students, Jennifer Walker. It looks at rates of sea level change on the y-axis in century scale bins, and you can see that in the 20th century, this is for the US Atlantic coast, the rate is around 3 millimeters per year, 3 times greater than anything in the historical period prior to the Industrial Revolution, driven primarily by global processes. The IPCC report also, for the first time, clearly illustrated that the rate of sea level change was accelerating. So from 1901 to 1971, the rate was some 1.3 millimeters per year, and it tripled to around 3.7 millimeters per year from 2006 to 2018. I published a review of sea level changes in time and in space, and this is one of the figures. So I compiled together all the rates of global mean sea level change that were in the published literature, be that derived from instrumental sources of tide gauges or instrumental sources from the satellites. In the red is the rate in the 20th century with an uncertainty, and in the blue is the rate in the 21st century. So it clearly illustrates that it doesn't really matter which data set or author you use, there is a significant increase in rate from the 20th to the 21st century. Well, the nuts and bolts of the chapter 9 of the IPCC is on sea level projections, but the sea level projections need to be placed in a context against other high profile literature. So we have the AR6 projections, and they're put into a context compared to the 2019 special report from the IPCC known as SROC, compared to the AR5, the 2013 report from the IPCC. And it was also really nice to see that it was compared also to a publication we produced at the Earth Observatory of Singapore, looking at sea level changes in 2100 and 2300. Now, it's important to make sure that the ARC projections are built upon previous knowledge, because sea level change is complex. It is driven by a variety of processes illustrated on this schematic, both global, regional, and local. I'm just going to go through these to you. We've got some little animations that we drew to try and illustrate this. So on the global scale, there are 2 major drivers. On the bottom animation is what is known as thermal expansion. If you increase ocean temperatures, the water occupies a greater volume and sea level goes up. And ocean volume changes have dominated sea level in the 20th century, being a contributing factor of somewhere around 50%. In the top panel, we look at a mass problem. So if you increase atmospheric and ocean temperatures, what we've seen from looking at our ice sheets in Greenland or Antarctica, or glaciers and ice caps, is that they will melt through the hydrological cycle, be added to our oceans, and sea level will rise. Our glaciers were the most susceptible, so of this mass problem, they dominated in the 20th century, contributing somewhere between 30 and 40% of sea level rise. But worryingly, in the 21st century, it is our are ice sheets that are contributing. Greenland, for example, holds around 7 meters of sea level equivalent and is currently contributing around 1 millimeter per year to the global average sea level rise. But it is Antarctica that is of a great worry to scientists because it has such a colossal amount of water contained within it. The Antarctic ice sheet is twice the size of Australia, which means it's 20,000 times the size of Singapore, 2 to 3 kilometers thick, and has enough water within it to raise global sea levels by a colossal 65 meters. When we get back down to the regional scale, it starts to get a little bit more complicated. Two of the dominant processes on the regional scale in the top panel, it's known as glacio-isostatic adjustment, and in the northern hemisphere, in regions that are near or underneath extinct ice sheets that existed 20,000 years ago, this process is the dominant cause of spatial variability of present and future sea levels. So 20,000 years or so ago, there was a large ice sheet in northwestern Europe and North America. It depressed the solid Earth. When that ice sheet melted, the land uplifted, and it's been continuing to uplift for 20,000 years because of the slow response time of the solid Earth. Conversely, at the margins of these ice sheets, the land was uplifted 20,000 years ago and is subsequently subsiding. On the bottom panel is the change in sea level, or a sea level fingerprint that would be produced from the melting of our present day ice sheets. So as I said, Greenland and Antarctica are colossal in mass, and therefore they have a gravitational attraction towards them of the ocean surface. If the ice sheet loses mass, the gravitational attraction is weakened and the water level will move away. And so we ran a variety of models looking at this. So for example, if Greenland was to contribute 1 meter of sea level to the global ocean, the sea level effect in the tropics in the far field would be somewhere around 1.2 and 1.3 meters. So much greater than the global average. And then finally, when we get down to the local, we have problems when projecting these processes. They are either unconstrained or we simply don't have the data, but they are a significant influence. So we have groundwater withdrawal. So groundwater withdrawal from aquifers used for industrial, commercial, residential, agricultural use will remove the water, the land will sink, and therefore sea level will rise. And this influences many cities in Southeast Asia, such as Manila, Bangkok, Ho Chi Minh City, etc. And a particular hotspot is Jakarta. In Southeast Asia, we have one of the most tectonically active regions in the world. And so between and during an earthquake, there will be significant changes to land height, which would influence sea level. But currently, this process is not included in any sea level rise projection from the IPCC. Then we have processes that are poorly constrained, such as local atmospheric or ocean circulation that can cause changes in sea level of several tens of centimeters existing for decades. And so a real area of research within the Earth Observatory is to downscale global, regional to local oceanographic models to understand this process. So I'm now going to show you some projections that are built around the processes that we can constrain. We're going to look at the two end members of the IPCC's shared socio-economic pathways. So we're going to look at the low emission future, SSP 1.9, which is akin to the Paris Agreement that we've already has already been mentioned. And then I'm going to look at the upper extreme, which is SSP 8.5. It could be considered not really an upper extreme because this is the business as usual climate scenario that we have been tracking for the past 30 or so years since the first generation of IPCC models in 1990. So we're just going to look through a few graphs here. So we're going to have time on the x-axis, sea level on the y-axis. In the blue is the median or the 50th percentile of the low emission, and in the red is the 50th percentile, the median of the high emission. And then we have a series of boxes here that look at what the IPCC calls the likely range, the processes that they have the most confidence in, and we're going to look at the 17th to the 83rd percentile. So if we look at the projection of global mean sea level for the low emission scenario, we can see if we look at the 50th percentile, no significant acceleration in rate from the present day values of around 4 millimeters, gets up to around 6 or 7 millimeters by 2100 with a magnitude of change of around 0.4 of a meter. When we go to the high emission scenario, there is this acceleration in rate. We get values of somewhere around 10 to 15 millimeters per year towards the end of the century. This is really crucial because it means that global mean sea level will top or cross a variety of thresholds of our coastal vegetation, be it mangroves, salt marshes, submerged aquatic vegetation, or corals and their ability to survive. What is really needed is to look at the regional scale, and the NASA data portal, which builds upon the methodology produced by the IPCC, enables us to do this. So here in Singapore, we can look at sea level change, and sea level change in Singapore is very, very close to the global mean. 78 centimeters or 0.37 of a meter, very, very close, differing by just about 1 centimeter from the global mean. When we look at the 83rd percentile, there is an increase from what it was previously about 1 meter to 1.2 meters. That increase is associated with that gravitational changes to do with melting at the poles, increase in sea levels at the upper thresholds in and around Singapore or elsewhere in the tropics. So Singapore is close to the global mean. Other regions of the globe differ very greatly. So in Oslo, in Norway, for example, the region here has 50th percentile of around 0.4 of a meter, similar to the low emission of the globe, and a 50th percentile at the low emission of negligible change. The reason for that is associated with the extinct ice sheet that existed 20,000 years ago and was sat over Norway. It depressed 20,000 years ago and it's uplifting, and the rate of land height change is equivalent to the rate of increase in ocean volume and ocean mass. New York City is greater than the global average. The primary reason for this is that New York City was at the margins of the Laurentide ice sheet that existed 20,000 years ago, therefore was uplifted and has been subsequently subsiding. So you get an increase in ocean volume and a decrease in land height changes. If New York City is slightly greater than the global average, we then turn to Manila, which has rates far exceeding the global average, 1.3 meters, 0.9 meters above sea level, low and high emission, driven by groundwater withdrawal. Since the development of Manila in the 1960s, rates of current day sea level are around 15 millimeters per year, 5 times the global average. If we continue to deplete that freshwater aquifer, we get these catastrophic rises. I'd just like to finish with that there are many sort of advances within the 6th assessment report compared to its predecessors. One of them was to look at high impact, low likelihood events. Events that we knew the theory about, events that if we went back through the geological record, we could identify that they had occurred. Therefore, depending upon temperature forcings, they are going to occur in the 21st century or beyond, but we don't exactly know when. So regarding sea level, it's looking at 2 processes that would influence, in particular, the Antarctic ice sheet. And these are marine ice shelf instability or marine ice cliff instability. Antarctica currently is not contributing a significant amount of water into our ocean basins, primarily because the ice shelves buttress the land-based ice. These ice shelves, we know, are very, very susceptible to collapse and have collapsed in geological time. If they collapse, then land-based ice from Antarctica can go into the oceans and significantly rise sea level. And this can be amplified if this process is combined with ice cliff instability. And there are a variety of models that take into account both of these, and they indicate substantial rises in sea level. So what does that mean for Singapore? Well, when we're looking at Singapore out to 2100, the mean change from about, median changes from about 0.8 to 0.9 of a meter, and we have a significant increase at the upper tail. But its particular impact is if you run the model over into the 21st century, then these processes from Antarctica will have a significant increase in sea level. So we go up to 2.1 meters by 2150. And if we look at the 83rd percentile, you're looking at a rise in sea level of around 5 meters. Now, the Prime Minister of Singapore stated in 2019 that sea level rise was an existential threat to Singapore and other island nations. Well, if we have high impact, low likelihood scenarios, a 5.2 meter sea level rise is not an existential threat, it's an existential reality. So to summarize, the IPCC is able to produce a variety of sea level projections from a variety of different emission scenarios, ranging up to around 0.7 of a meter, 50th percentile by 2100, and 83rd percentile of approximately 1 meter. The community is significantly concerned by changes in ice mass from Greenland and Antarctica, which could contribute an extra 1 meter or so by 2100 and several meters thereafter. We have to collect data on past and present sea levels to calibrate these models that project the future. And that really is the aim and focus of the Earth Observatory of Singapore. Thank you, everyone.
Thank you so much, Professor Horton, for giving us one of the findings from the AR6 report of the IPCC. So let me remind everyone again to keep the question coming into the Q&A box. We have seen a number of questions already, but more are very encouraged. So our next speaker is our longtime friend, Jenny Frankel-Reed. She's a senior program officer on climate adaptation in the agricultural development team of the Bill and Melinda Gates Foundation. Prior to this role, Jenny served as a senior climate change specialist with USAID, and in that role, she provided technical support to programs in 20 countries across the world, in Asia, in Africa, and Latin America. Jenny also coordinated the USAID and NASA SERVIR partnership, and that's when I met her, and helped more than 30 developing countries to take advantage of satellite data for adaptation to climate change. Today, Jenny will tell us a bit more about the Gates Foundation climate resilient agricultural work and how geospatial technology was useful in that work. Jenny, the floor is yours.
Thank you so much, Kieran, for the introduction. It's really an honor to join this SERVIR-Mekong Symposium, and I really am excited by the commitment of the hosts and the participants to rigorous scientific solutions for sustainable development, and particularly that this is a conference by and for organizations in the Asia region and their partners. I think this kind of conference helps to set the agenda, so thank you for the invitation to learn, listen, and support your work. So next slide, here's what I'll talk about. I'll share how the Gates Foundation's agricultural development program is looking at geospatial solutions to climate resilient agriculture, touch on the latest evidence that we've been studying that may help us understand the challenges and also what works. And I'll share some areas that we see promise in for geospatial technology solutions. Next slide. So the Gates Foundation does not have a long history of investing in climate change outside of longstanding investments in improved crop and livestock genetics for stress tolerance in the agriculture portfolio. But Bill Gates was a co-chair of the Global Commission on Adaptation in recent years, and since then a strategy has been underway to increase the focus of the Foundation's agriculture portfolio on climate challenges. So what we have seen so far is our portfolios, including R&D, digital farmer services, livestock, and more, really pivot toward a climate focus. And what we hope is that with some additional resources, we can deepen our climate work across portfolios and add some new areas for climate work next year. So you can see some of our investment priorities here, and that many of them offer entry points for geospatial technologies and solutions. And you probably know that the Gates Foundation is a group of technology optimists, so that those entry points are really important. So advancing next generation ag research and development, how do we bring improved technologies and genetics into the agriculture sector more effectively, supporting more responsive and inclusive country systems that are empowered with the data and science that they need to make good decisions, efficient and sustainable use of land and water resources, delivering more timely and actionable information bundled with input advisory and financial services for early action on agricultural risks, including climate, and then focusing on resilience and inclusion for the most vulnerable smallholder farmers. So there is a really important equity dimension to all of this as we see it. Next slide, please. So I said I would talk a little bit about the evidence that has been informing our strategy, and the evidence that we see is really, there's a lot of evidence out there. This is one interesting piece on the challenge, which comes as no surprise to all of us, I'm sure, but climate change has already had a very measurable and dramatic effect on agriculture. So despite really significant advancements that have been made to feed the world in the last 60 years, and a lot of progress has been made, this study led by Cornell shows that global farming productivity is 21% lower than it could have been without climate change. So if you actually do one more click, so on the left side, you can see the Asia value in that bar, which is around 20%, and different regions have been affected differently. But you can see how different countries in the Asia region look in terms of the impacts of climate change over the last 60 years on total factor productivity. So this is measurable over that long time horizon, but it's also backed up by what we know about interannual, year-to-year variability, and some other research validates just how much climate change does reduce productivity, can reduce productivity, or boost productivity, depending on if it's a good year. So 32 to 39% of observed yield variability for maize, rice, wheat, and soybean is due to climate factors, according to a 2019 study. So we're seeing this issue from one year to the next in terms of yields, and it has a huge aggregated impact over time. And this means a lot in terms of people's incomes, nutritional outcomes, economic growth for agricultural dependent economies, as you might imagine. Next slide, please. So again, on the evidence that we have seen, I think it's really important to, and it was great to hear about the AR6 Working Group 1 report, that really we can't say enough how soon 1.5 degrees of change may be, and how severe 2 degrees may be. So just to sort of motivate and all of our scientific work, global average temperature has warmed about 1 degree over about 120 to 150 years. We're at about 1.1 degrees warmer today than the historic global kind of pre-industrial average, but we're on pace to warm an additional 0.5 degree in about the next 20 years. So that pace of change is really quite striking. That the world we're living in now is 1.1 degrees warmer. 1.5 degrees is coming quite soon. The second point is that 2 degrees is significantly different from 1.5 degrees. So at 1.5 degrees, 14% of the world's population will be exposed to severe heat waves 1 in every 5 years. And at 2 degrees, that's anticipated to be 37% of the population. And this is just a snapshot from South Asia. In 2015, there was a really deadly heat wave that killed thousands in India and Pakistan. And at 2 degrees, in a 2 degree warmer world, that degree of heat wave could occur annually. So you can see just how significant the adaptation challenge really is. And the darkest color in that image is 110 to 120 degrees Fahrenheit. So very, very stressful conditions for agriculture, people, natural resources, animals, etc. Next slide, please. So this is another, as we look at the evidence, another area in terms of the challenge that we're very interested in, which is better understanding land restoration, soils, carbon, and the role of land and soils in climate solutions, and also in resilient food systems and agricultural productivity. So here we have a little bit different degree of mature science, where what we do know from recent studies is that models have underestimated the amount of carbon released from soils in a warming climate, and that models that predict the impacts of land management on greenhouse gas emissions have been overly optimistic about soil carbon sequestration. So where this really leads us in terms of where this evidence gap, what this evidence gap means is that we need more geographically specific analysis focused on sustainable food production, land management, avoiding land degradation, avoiding further carbon loss, and what makes sense in a specific geography, given the soils, given the agricultural practices in a region that are going to be practical. So the next slide, shifting a little bit to the evidence on what works, because just as much as we need geospatial technologies and earth system sciences to help tell us about the problem, we also need it to tell us about what works. So this is some recent findings from a small sample, but an important one, from the Global Commission on Adaptation's Blueprint for Digital Climate-Informed Advisory Services that came out earlier this year, that showed investments in digital climate advisory average a 30% increase in productivity, a 20% increase in farmer income, and very, very compelling cost return ratios. So this came from a combination of public and private sector digital advisories.
One with
another
ECP and the other one with...
Sorry, but another key component here is that in addition to sort of the products and the services that are provided and how important those are and relevant those are to productivity and farmer incomes, is some of the key components that cross-cut, including open data that we heard about earlier, but use of international data quality standards, the ability to sustain some of these platforms and services, transparent communication about accuracy and uncertainty. So there's a lot that goes into these kinds of products, but they are very promising in terms of the value to agriculture and smallholders in particular, who may not have all of the access to pay for the kinds of data that might help them. Sort of the larger landhold owners. So the next slide, please. This is just another important factor that we have reflected on that I think is important, that there's not one silver bullet or one sort of solution that we are going to lean on. It's really important to bundle these adaptation practices and bundle information with other kinds of support. So this was basically a study that found, how many studies on climate resilient crops included these different factors: extension, awareness, information, farm inputs, finance instruments. These were very useful, and importantly, they do not work in isolation, but are mutually reinforcing in terms of effectively reducing risk. So next slide, these are my last two slides. So here, I think, is where we are in terms of some of the Bill and Melinda Gates Foundation, BMGF, geospatial technology investments that we're making in climate smart agriculture. One is called, and this is just a sample, but a few of them, enabling crop analytics at scale. So this program recognizes that, yes, there are some very successful methods and tools that have been developed, but how do we make sure that that kind of analysis is available at a much greater scale, available to much more people? And that one of the key challenges is dramatically reducing the cost of collecting ground truth data so that remote sensing data can be more effectively and accurately applied. So some of the outcomes you can see there, promoting standards for collecting and aggregating high quality training data, facilitating the scaling of trading data set creation and exchange, and then improving access to repositories of updated ground data and core layers in the ag sector to enable really scalable, replicable, satellite-based analytics for agriculture. And there's a website there where people can see more. Another one that's just getting started is called Adapta. This, I think, is a good illustration of the kinds of organizations that need to be working together more. So this is helping integrate climate risk assessment into a lending facility for small and medium enterprises in Kenya. And in doing that early stage, cost effective, very easy for the financial sector to use kind of a review, remote sensing data is really extremely useful in doing that. And then you need to do more local data collection at a second stage. But we're hoping that by bringing more climate scoring tools and EO applications into risk assessment in a very user-friendly way, it will help to unlock more financial investment and credit to the ag sector. And then I won't go into the last one for the sake of time, but in too much detail, but how do we use Earth observation information in a way to better characterize future environments so that breeders, seed companies can actually have better insights into the future. So my closing headlines are that there are a number of key scientific questions and systems where we need to better understand interactions and not just focus on impacts and risk, but also evaluating and adjusting our solutions. That we have very strong evidence on cost benefit ratios, but we need more climate ready analytics, product services, and better dissemination and bundling to reach really more people and get greater uptake of those. And then finally, this is similar to Barb's point about partnerships, but more creative engagement and partnerships across sectors, including public and private, the financial sector, academia, et cetera, because the scale of these challenges and the urgency of addressing them is really quite urgent and severe. And so we can't any of us do it alone. Thanks.
Thank you so much, Jenny. Always a pleasure to hear you talk. And thanks for giving an evidence of climate change, and more importantly, get us to start thinking about the solutions that we can work together to address that issue. Final warning for the audience, please keep the question coming into the Q&A box. We are taking all the questions and try to get the answers for you in the last part of the session. Now, our final panelist is Dr. Pete Apanchen. Pete is the Senior Resilience and Climate Adaptation Advisor at USAID in Washington, D.C. Pete provides strategic and technical inputs on climate adaptation programming at USAID. He provides support on strengthening adaptive capacity to address climate change, hydroclimatic disasters, food security, and land use and natural resource management. Previously, Pete worked on climate change at the Environmental Protection Agency, EPA, and has been a biologist with the U.S. Fish and Wildlife Service. Pete, the floor is yours. Please share with us what USAID is thinking about climate change.
Thank you so much, Pirnan. And I don't have a slide deck to show, so bear with me. Thanks so much for inviting me to this symposium. It's a treat and an honor to be on this panel with such accomplished colleagues and to be working so closely with the SERVIR-Mekong team at ADPC. And I'd like to start by reviewing a few points, some points that you're already aware of. So this isn't something new. Indeed, we know that the world is warming. Scientists have been telling us this for decades. But why I think it's important for me to start from a place of shared knowledge is to emphasize the point that RDMA's mission director, Steve Olive, made, which is the US government's prioritization on the issue of our lifetime, climate change. On January 27th, President Biden released an executive order on tackling the climate crisis at home and abroad. And this executive order places climate at the center of foreign policy. And if it's not at the center of domestic policy, then it can't be too far from that center either. The administrator for USAID, Administrator Power, has also made it clear that climate change is a top priority and addressing it is an important part of what USAID does. And there was great positivity that our previous speakers and panelists brought to this conversation, with Barbara and Dan and Jenny talking about technology optimists. I think Ben, presented some very sobering information on sea level rise. And I'm going to start in that sort of sobering spot and try to work our way out a bit, because I think that hope is so important in keeping us going with this, as is climate action. So just to start with a simple framing of the problem, climate change is upon us now, and the impacts and the risks are escalating. Human activities are indisputably causing climate change. We're dangerously off track from meeting the Paris Agreement's goal of limiting global warming to 1.5 degrees Celsius above pre-industrial levels. The changes in the climate are widespread, they're intensifying. Human influence is making extreme climate events more frequent, more severe. It seems that this year, the world has moved to a new normal of experiencing one climate change impact after another. Scalding heat waves, heavy rainfall and floods, droughts and catastrophic fires. And that brings, of course, with it challenges of air quality. Just over a week ago, an article was published in Science warning that even under conservative scenarios, people under 40 will experience climate change unlike anything humanity has ever known before. It's really hard to imagine what that world looks like and what that means, what it means in terms of the future for our children. Without immediate urgent action, climate change will push many more people, millions more, into poverty. Many of the hard-fought development gains will be lost as climate change undermines food security and water security, as it threatens health and well-being, as it increases our exposure to disasters, the interconnections of climate and conflict, human displacement. Climate change and these interrelated risks will further economic disruption and exacerbate global inequities. And nobody is immune from the impacts of climate variability and change. However, the impacts disproportionately affect the most vulnerable populations. And climate change will continue to exacerbate existing injustices and social and economic inequalities. So even if we were to stop all greenhouse gas emissions today, we're still facing a very new and very dangerous climate, both today and going into the future. However, some changes could be slowed and others could be stopped or reversed by aggressively reducing our greenhouse gas emissions. We must get to net zero emissions in order to stabilize the rise in temperature. When we reach this net zero goal, will determine how much warmer the planet becomes. So what matters are the actions that we take today. And the sooner that we start a sustained global decline in emissions, the greater our chances of keeping a 1.5 degrees Celsius average within reach, recognizing the challenges of that. So there still is time to avoid the worst impacts of climate change. If we take strong climate adaptation action now, then we can prevent most of the poverty that is projected to result from climate change occurring over the next 10 years. The costs of doing nothing are significant, but so are the opportunities if we act now. And at USAID, we work across 3 climate pillars. There's natural climate solutions, sometimes called sustainable landscapes, which seeks to reduce land-based greenhouse gas emissions. Climate adaptation, that's the ability of people to be able to cope with the effects of climate change, both in the present and the future. And renewable energy, which really recognizes that the energy sector is critical for combating climate change. And at USAID, we're really making a push to mainstream and integrate climate change outcomes across all of our development and humanitarian portfolio. and the interventions that come with that. So operationalizing these 3 pillars takes on a lot of shapes and forms at USAID. So the program that I help to manage with many other folks at USAID and in collaboration with NASA and with a network of partners at national and regional institutions such as ADPC is the SERVIR Partnership. And this is an important intervention for programming in climate adaptation and in sustainable landscapes, specifically for food security and water-related disasters, land use and land use change, and air quality. So using satellite data and geospatial technology, SERVIR co-develops innovative solutions through a network of regional hubs to improve climate resilience and sustainable resource management at multiple scales. So with SERVIR, we pride ourselves on our approach to a variety of development challenges. And that approach is a user-centric one. We collaborate, and this approach really comes to life in our service planning toolkit. The service planning toolkit was originally developed in 2017, and in June of this year, we released an update to the toolkit. And this update has made the service planning approach more inclusive of women as co-developers. The improvement really helps to make our work more responsive to the differentiated needs of men and women beneficiaries. The service planning toolkit, it came about because we didn't want to deliver geospatial solutions that didn't meet a demand and that weren't co-developed with our partners. SERVIR's approach, really, it's for the service developers to check their assumptions at the door, and then to undertake a consultation process with users to really understand the context of their needs. And we found that this is really a requirement for a solution to be effective, to be well used, and for it to get traction and uptake. So the toolkit orients SERVIR to work with partners and collaborators in the design and delivery of geospatial services. The planning approach is anchored in consultation and in user need assessments. And the method within the toolkit, within the service planning toolkit, facilitates a deeper understanding of the contextual landscape of the development problem or challenge that we're approaching. And by using this, our hub partners are better able to understand who is impacted within their region, what type of data and information are needed, how can that information be communicated and tailored to a diverse audience, and where is there a need for additional capacity to be built. So this approach has helped to improve and adaptively manage SERVIR's geospatial solutions and services, such that they're better able to strengthen that adaptive capacity and to build climate resilience, building our resilience to climate variability and change. And central to the service planning approach are the users themselves, who join with the SERVIR hubs, with USAID and with NASA in co-developing their own geospatial services for their communities. And this shift has helped SERVIR to co-design services in response to demand, promoting usability and sustainability of services. And I'll add that the service planning toolkit is freely available at the website for SERVIR, servirglobal.org, or is it .net? .net, I think. So the view from space and SERVIR's use of geospatial information and technologies also brings advantages of scalability and replication. Something that's amazing about this global partnership and this network is that collaborations can form, and there's exchange of knowledge and learning and exchange of methodologies, so that solutions which were designed to address a problem in one region can be picked up and applied to regions facing similar challenges. And so while local context and partners are critical components for informing the needs and the design of a SERVIR service, the algorithms and the automated techniques can often be repurposed to another area. An example of this is with SERVIR-Mekong surface water mapping tool, which was designed to assess the risk of floods and impacts from existing and proposed dams. And it turns out that this service also had an application in West Africa's Sahel region. So using the work that SERVIR-Mekong had done to map out surface water, SERVIR West Africa was able to design an ephemeral water body service to support pastoralists and their search for seasonal ponds during the dry season. And of course, in the dry season, finding water is critical for livestock. So this service has the potential to be further scaled for use by pastoralists beyond the Sahel in Eastern Africa. And recently, SERVIR-Mekong's flooding service and tools they've been used to penetrate through cloud cover and have been used in completely different regions outside of the Southeast Asia context to look at flood mapping and flood extent in Central America after several back-to-back hurricanes hit the region. And that information was then quickly used, and it was requested by local disaster response authorities in Central America. So SERVIR is a fantastic example that demonstrates how geospatial information can be used productively to enable solutions to identify and manage climate risks. And the importance of that, I don't think, can be underestimated. Timely information is so critical in so much of the decision-making processes, and there's, in climate, it's so needed. So clearly there is enormous potential for the continued application of Earth observation information and to have that go further in how it's delivered and in addressing the climate crisis. Free and open satellite data can be used to identify and manage climate risk at scale. And geospatial tools and climate services are very important in climate adaptation. The final point that I'll end on is that USAID is in the midst of developing a geospatial strategy. So we have a draft results framework. It has not yet gone public, there was also a point earlier on in the upcoming climate change strategy, but this is the geospatial strategy. And this is an exciting development because I think it reflects the value that USAID places on the power of geospatial analysis and technology to inform USAID decision-making. And that helps to strengthen our humanitarian assistance, to improve our development, our international development and development outcomes, and this includes USAID's whole of agency response to the climate crisis. So once this is available for public comment, I will certainly be sharing this with our SERVIR network and colleagues at ADPC. Thanks, and back to you, Pierre.
Thank you so much, Pete. It's great to hear that USAID is developing two very important strategies. So we'll look forward to hearing more about those. Now we have come to the close to the presentation. We have heard from all the panelists already. Now it's time for us to turn into a bit of a conversation. And for the audience, please keep the question coming into the Q&A. I only have a few questions that I want to pose to the panelists, and then after that, I'll just go through the questions from the audience. I just want to go back to the idea of using science to first understand the climate threat and then use that information to address it. When we all understand that science is a very important aspect for addressing climate change, but from our own experience, it's not always that every science is going to be adopted and turned into actions. We understand that science has to be appropriate to the context, to the users, understood by the users, and that will increase the likelihood of user picking it up and use it. So I want to pose this question to Ben and Jenny. First to Ben, from your own experience as part of this IPCC AR6 development team, how do you think this AR6 report can inform global leaders as well as actors on the ground to take that information, to take the scientific findings to take and turn them into actions? Ben?
That's a great question, and I think it gets to the heart of the matter that without science, you can't truly look at the impacts of climate change. I mean, I presented some of those findings from the IPCC, and then sort of Pete followed up my sobering tale with further sobering facts. You know, I've been studying climate change for 25 years, and there's sort of a phrase that I like to say that if you knew what I knew, you would be very, very scared. of what the Earth can do. We can go back through geological time and state that when temperatures were about half a degree warmer than today, I think Jenny mentioned these thresholds of 1.5 or 2 degrees C. So 125,000 years or so ago, temperature was half a degree C warmer than today, and sea levels were approximately 5 meters higher. When temperature was 2 to 3 degrees C warmer than today, sea levels were 10 meters higher. Our geological data provides the facts that the Antarctic ice sheet is susceptible. And, you know, we talk about climate change as an existential problem, and with sea level rise, just looking at one of the impacts it is. But if you want to get down to the local level, particularly in Southeast Asia, we have a huge problem with the lack of data. The instrumental record. So we always try and look at the instrumental record to calibrate the data. And in the north, we're very biased by the data that's available in the Northern Hemisphere. So in Northwestern Europe, you can get instrumental data that goes back to the 1600s. When I worked in the United States, I could look at the battery tide gauge in New York City, goes back to the 1850s. In Southeast Asia, where 600 million people are susceptible to sea level rise, there's only one tide gauge that's greater than 60 years old. That's in Manila. It's contaminated by earthquake. We certainly don't have any data to constrain it. And that's one of our huge problems right now. So if you want to get data down to the local, if you want to get projections down to the regional and local level, to really involve private and public partnerships because they're interested in the local level, our constraint is a lack of data.
Great, thank you, Ben. Let me turn things over to Jenny. From your work in the past decade or so, I mean, you interacted with both scientists and also people on the ground. And you have shown to us in your presentation that there are some programs that really worked in bringing science, find an entry point and then applied it. What were the elements that made those programs work on the ground? Can you share us with some experience and examples, please?
Yeah, I think it's a really important question, how we go from big system science and motivating attention to these problems to locally relevant science that can support action. And, you know, my experience is that there is just a lot of awareness of the challenges and a huge gap in terms of understanding, having the degree of evidence that we would need to actually support the decisions on resource allocation, decisions on where to start, decisions on what to do now and what to plan for down the road in 10 years from now. So I think the IPCC reports do a fantastic job of synthesizing the gravity of the challenge, and we need to do more to connect really with local concerns, what the kind of information is that people really need. So what I would say, what I've seen work is that, more local partnerships, more, sort of downscaling of this information, starting with some of the no regrets investments where we know this works against this kind of stress. We may not know the magnitude of change or necessarily the timing of change, but we know regardless of the degree of climate impacts, this will be a no regrets investment. That's also a really successful and important approach. But I would say that we have looked at where does adaptation work well and what are the characteristics of that kind of a evidence-based set of partnerships. And oftentimes in a lot of contexts, it is having an academic partner that has the ability to provide neutral analysis that's rigorous, but also an interest in the local geography. So, a commitment to supporting, let's say, flood management in a region and a program or something on that, or a group of engineers that want to become more well-versed in that kind of science with public sector and private sector partners and audiences that really need to consume and make investments on that information. So I think looking at, in a geography, who are the actors? Who are the neutral parties? Where does the capability lie to generate valid analysis? And then who's got the ability to formulate actionable questions that science can really dedicate itself to answering, instead of just saying, here's our model, here's our report, here's our data set, really understanding what it is that's motivating decision makers and tailoring that to their needs. And I think, ADPC is in that business of figuring out what are the problems, and then how do we go back and pull what we need from the science to answer that. And I think there are a lot of organizations that are very interested in doing that. And so the question is, where are the capacity gaps? Where can donors and governments, bridge the gaps between the motivating questions and the capabilities to help answer them?
Thank you, Jenny, and thank you, Ben, too. I mean, from what Ben has said about data access and data availability, to Jenny's, your point on knowing the actors, knowing the parties and their roles, this to me is about partnership. So that's a good segue into the next question for Barbara and Pete. In your view, actually starting from Barbara, your presentation about this hyper partnering is very intriguing. Can you tell us a little bit about how you bring the private sector entities, which has a wealth of information and data, to work with the public sector, and what is the gap that you want to address going forward on that realm? Barbara.
Yeah, thanks for that. And that's a really good question too, because it's not easy. It's not easy on any of the hyper partnering. It just takes a lot of time, and I think because our business models are different, our communication and the terminology we use is different, and I think a lot of people feel like it's just not worth the time that it would take to establish those partnerships. Honestly, to be totally frank, I think the only reason this GHG monitoring between the public sector and the private sector took place is we had a couple people, one of which was me, that had lived in both worlds, that said, listen, let's do that. Let's reach out and work with GEO, because I used to be in that organization. And so it takes people, I think, kind of either jumping boundaries or jumping organizations to reach out and kind of undertake some efforts like that. And I think by and large, I think it's just because it's just easier kind of staying kind of in our own lanes and doing what we have to do versus taking the extra time to work outside. So it just takes a lot of work. That's all I can say. And it takes a couple of people that are willing to kind of jump those lanes to reach out across those boundaries.
Thank you, Barbara. And you were correct. I mean, partnership always started out with a few people knowing each other, and then that kind of knowing each other grow into a bigger group of people. And that's the definition of partnership in my book.
You're right. You're right there.
So Pete, what about USAID? I know that you value very highly the partnership with the private sector. What do you think we should do to increase this partnership, to increase the use of geospatial technology to address climate change?
Right. Thanks, Piranan. I mean, I think that I'd be very excited to have a follow-on conversation with Barbara and sort of with the whole SERVIR network more broadly on just finding points of connection. I think that the partnership, there's so many different ways of defining it and measuring it and understanding, like, when is it that we're partnering, formally or informally. And just, thinking also in terms of networks, and the SERVIR network is quite large and expansive. Geographically, we cover quite a bit. And so that's one area. But there's been some more formal partnerships that I think there's a lot of potential to really bring in expertise that may not be possible or that can reach a scale that would otherwise be unachievable if we were to go it alone. And so two that I would pinpoint are, one was Ensure Resilience, the global partnership. So it's kind of a mashup of insurance and resilience to get Ensure Resilience. And this is a coalition that looks at the use of information, whether it's from the ground or space with satellites, to increase lead time, to build out early warning systems. And I think here's a really important piece of it too, to get a disaster risk finance. So the financing component, where you're able to bring in private sector and unlocking private finances into this space, and then bringing in insurance products for transferring risk, is an area of opportunity. There's a lot of people already doing work in some of these components of risk transfer. And so that's a space, I think, from a climate adaptation perspective, that is just ripe for going bigger with partnering. Another partnership within that same realm is REAP, REAP, Risk Informed Early Action Partnership. So again, looking at early warning systems, risk transfer, and private finance for unlocking a rapid response to somebody who has been faced with a climate disaster, or to get finances to them in advance of that, so that they can have and information in advance of that, so that they can have an action that they're able to take that reduces their risk, potentially saving lives, livelihoods, and assets. But yeah, partnering is absolutely a piece of the pie of where USAID sees interventions. It's not just about putting out solicitations and funding those with implementing partners.
Thank you, Pete. One piece of the pie. But yeah, this is very interesting. I feel like I have a ton of other questions, but I want to make sure that I can address the question from the floor as well. So I'm going to read out some of the questions that I thought would be key. The first question, very interestingly, I'll just read it out loud. The science is crystal clear on the devastating impact of climate change. The issue is the lack of global political will to do more, to really walk the talk. Can any one of you speak about solutions that have been effective to ignite the political will, to do what will be needed? Anyone?
Well, I can start, and then I'll see. I'm sure that others would be interested. I'd be interested in hearing from others. Coming in from the U.S. government, we all know how the pendulum has swung and swings, and without, when you've got kind of all of the priority locked up in the executive office, without the backing of laws and a Congress to support that, or whatever the governance body is to support that prioritization, that pendulum can swing and can be an unstable priority. So I think that that's, from a U.S. experience, to this point of political will. Sometimes it's hot, sometimes it's cold.
Thank you, Pete.
And Pirnan, I can come in. I typed an answer in the chat that I'm not sure if it went into the Q&A or the chat, but I think Bangladesh actually has some good examples on the climate adaptation side, where adaptation in Bangladesh and in many countries is about good economic development choices. And in Bangladesh, you had a lot of coastal agricultural areas becoming too saline for rice cultivation that shifted to shrimp and aquaculture, for example. You also had very devastating cyclone events that really necessitated the government to take a hard look at, cyclone preparedness. and flood preparedness. And so you have pretty strong early warning systems and shelters that have been built to withstand very significant events and save lives. So I think more and more the adaptation challenge, at least, is going to be one that delivers economic and human development returns. But I think on the mitigation side, it's a little bit of a different question. But I think cleaner, renewable energy is more cost competitive now. But the question is often about financing, expertise, and removing any barriers to investment in cleaner energy solutions. But that's just one example from Bangladesh.
Great example, Jenny. I think Barbara would like to say something.
Yeah, I'll jump in on that, you guys, because this is just such an important topic. And, I've been thinking about it. When did former Vice President Al Gore kind of raise the climate challenge or flag? 20 years ago? That's almost 2 decades ago. I can only imagine how he must feel, about having spoken out and then being criticized for that 20 years ago. And one would say we're maybe not much farther. I got some advice when I was early in my career and said, it's not an issue until it's an issue. And I think what we've got to do is we've got to kind of switch. We've got to get the economics behind it. And now we're starting to see big companies come to the table and recognize the issue and kind of put their investments behind it. And I'm kind of sorry to say this because I have been a public servant, with the exception of this job that I just took in January. I've been a public servant for 44 years. It's just governments are so slow to move. And somehow until we get money behind actions, I think it's just not going to change. And I'm not really optimistic about how rapid, we'll be able to address these issues. And I kind of think I'm an eternal optimist, and yet I'm pretty discouraged about this particular topic. So sorry to kind of be down on this discussion.
Thank you, Barbara.
Can I just add an aspect? I think the IPCC report obviously provides some very concrete data on how we've changed the environments and their impacts, but it also provides a pathway for hope. It looks at a variety of these shared socio-economic pathways, and depending on which pathway we go along, will give you an indication of the impact on the planet. I think the COP26 meeting is going to be crucial because words are great, but actions are really, really important. And climate change is such a huge topic, we can't get it wrong. And we need to see indications on that. But there are changes in the government. You could say that you're hopeful because Chinese, European Union, and now the US are all stating they're going to go to carbon neutral by the middle of the century. But we need to move faster on that. I mean, the scientific community said that we've got now, well, they said this back in 2018, that you had 12 years left to peak your energy demands. We're now, we're now in 2021, turning to 2022. So the years left for us to peak are diminishing. And there are just so many take-home points about climate. Temperatures changed 1 degree C since pre-industrial. Look how many climate emergencies we have. If by 2050 it's 3 degrees C higher, how many emergencies we'll have. The US was just hit by Ida. It's really interesting. I wrote a paper in the Proceedings of the National Academy of Sciences saying an event like Hurricane Sandy would occur every 10 years by the middle of the century. Well, Hurricane Sandy was in 2012 and Ida hits in 2021. Scientific projections are scientific realities. It's incredibly worrying. And we have to make action, and that's individuals, communities, stakeholders, government, regulation. It's possible. possible. Governments have to move faster, but the private sector have to be really involved. You know, there are great possibilities. Nature-based solutions, I think, is a really interesting avenue. Here in Singapore, they're trying to think about it being the centre for monitoring changes in carbon in Southeast Asia. That's going to have to involve the satellite community to monitor biodiversity, monitor the ecosystems, monitor the carbon flux. That has great potential to preserve what we have and regenerate what we lost.
Thank you so much, Ben. There are a ton more questions actually on the chat box and the Q&A box, but I want to respect the time of everyone. We are already 1 minute past the hour. So let me tell everyone who posts questions that we will address your questions. You put your name on the questions, and if you register, we will have your email address. So we'll reply to your specific questions. I'm sorry that we cannot address all the questions in this very interesting first session of the SERVIR-Mekong Symposium, but I need to wrap up this session. So I want to thank all the panelists again, Barbara, Ben, Jenny, and Pete, for the very, very insightful presentations and dialogues that we have had over the past 1 hour. I think this we are just scratching the surface. There are a lot more to talk about, but hopefully we get the people and everyone here to start thinking about the solutions that we have to work together to address this climate change issue. If I look back a little bit on the things that you talk about, even though you talk about different things, right, but I picked up some common areas that I think would be key for us to remember. One is on open data, sharing accessibility to data and standardized data. Both Barbara and Jenny, you talk about the need to have the data open up. Ben, also you mentioned about accessibility to data, but this will be key for us to understand the climate change and the threat that it may bring to the society and the community. We talk about evidence-based approach. Every one of you talk about that, but again, it's not just science, right? It has to be science that can be adopted and used and applied by the users. We talk about partnership. Everyone talk about partnership. Very interestingly, Jenny, you talk about bundling of data and intervention. So to me, this is a key area that we will probably have to look into. Everyone will have to work together. Most importantly, for everyone, the impact of climate change is not equal. It's not equal for all the geographies. Even within the same geography, it's not equal for different population groups. So what do we do to really bring science and tailor it to the users, considering the needs and also the capacity, the understanding, the context of different user groups, so that they can use it and help us work together to address this very real climate change issue. So with that, thanks so much again, the 4 panelists. I think this has been very, very useful for all the audience. With that, let me hand the floor back to our MC, Kun Ekapol. Thank you.
Thank you very much, Dr. Piranan. Before we end the session today, let me remind you that today is only the first day of the 5-day webinar series. So the next session will take place on Thursday, October 7th, in which we will focus on how geospatial technologies can support flood and water resources management. Thank you for attending and hope to see you on Thursday.
Thanks, everyone.
Thank you.
Bye for now. See you soon.
Thank you, everyone.
Bye-bye. Have a nice day.
Bye.
Very much enjoyed this. Thank you, Piranan. Thank you, ADPC, Ekapol, and panelists.